Hello, good morning. After a short break, again, I like to say some informations concerning mineralogy of North Peru pottery. Samples were collected by Professor Andrzej Chrzanowski some years ago, and the area of collectioning, area of presence of archaeological sites, this is basin of mountains, river, Alto Chicama, Moshe Chiquacara, and Condebamba. I show you map after minutes. The 5 main types of ornamented pottery ceramic was selected, and each of these types were examined using mineralogical method at Academy of Mining and Metallurgy in Krakow. Huamacucho impressed, Huamacucho on white. There are this is a time where sites were functioning. When sites were functioning, 11th to 16th century, 10th to 12th century. Alto Chicama, late period, termination of time. Sausacocha, 7th to 8th century, and Cajamarca, 3, 6th to 9th century. And this is the map with location, showing the location of examined sites. This is not map of part of North Peru, and this is more detailedly shown where are sites. These sites are marked as spots, as points. We will start saying something about morphology of vessels. Huamacucho pottery vessels and types of decoration, various types. And this is Chicama, Alto Chicama pottery, and lower part is Chicama, and bottom part and upper part, top part, this means these vessels. This is Sukochoka, tak, top. And there are examples drawing of pottery made by Professor Chrzanowski, various types of vessels and various types of decoration. This is there are drawings of surface, decorated surface of pottery belonging to subgroup 1A selected. Next is subgroup 1B, shape of vessels, type of decoration. About mineralogy will be after some minutes. Ceramics representing group 2, shape of vessels, thickness of wall, there is scale, centimeters, and kinds of decoration. And subgroup number 3A, this is shape of vessels, scale, type of decoration, small spots, points, paintings, various things. More detailedly, all is described in article, in publication. I give you data at the end of lecture. Ceramics representing subgroup number 3B, bowls like these, and decoration. This is information mostly for archaeologists. Ceramic representing petrographic group 4. The small fragments, as you see, there is 3 centimeters, so pieces are small really, and wall is thin, about 1 centimeter. And there are drawings of vessel of Shimu culture and Kulimalka. Tak, Kulimalka 14. The number of samples is 40 and this is 52. This vessel were examined too. Something about mineral composition of separate groups selected. These analyses were done using polarizing light microscopy and thin sections of ceramic masses, and in each sample were measured, determine mineral composition, this is this in percent, and grain size composition in amount is given there. It's a number of samples. So, subgroup number 1A. What we may say about this, that it's not too much quartz. Quartz is not frequent so much. The amount of clay mass changed thermally is about 45% medium, and we have small participation of heavy minerals and opaque minerals. This is typical composition, mineral and grain size grain composition of subgroup number 1A. Subgroup number 1B, the amount of clay minerals changed thermally, clay minerals is about 40, 45, 48. This is slightly more percent. Slightly higher amount of the quartz, and appear more fragments of shell rocks collected in this place. Additionally, traces of biotite are present, rare heavy minerals and rare opaque minerals. Subgroup number 1C, it's low amount of in the pottery mass, it's small amount of clay minerals, and are fragments of shell rocks and fragments of igneous rocks. Not too much, but they are. A relatively high amount of quartz, 32%. Rare grains of plagioclases, opaque minerals rare, and heavy minerals. Mineral composition of subgroup of group number 2, and this group is a relatively higher amount of changed thermally clay minerals, and is between 50 and 65%. And additionally, there are fragments of magmatic rocks, 11, 10%, 15%, 22, yet so. Fragments of sandstones, rare in pottery generally, in pottery of Peru. Rare quartz grains, not too much. Rare plagioclases are present or not. Opaque minerals are present in each sample. There are mostly ore minerals, or charcoal is black under the microscope, and very rare heavy minerals. Mineral composition of subgroup number 3A, ceramic number 3A. The ground mass is between 52 and 75, so it's higher. This is a rare case, but generally ceramic mass is composed of high amount of clay minerals. Quartz 10, 15, 17%. Rare plagioclases, but they are up to 20%. opaque minerals and heavy minerals range. Mostly pyroxenes, amphiboles, and ore minerals, some ore minerals. And this next group, rich, a lot of samples were analyzed. The amount of clay mass is between 55-57% up to 69%, so it's medium. This proportion between clay mass, clay components and other grains are more or less similar in all samples, 50 to 50, 60 to 40, something like this. And in this group of pottery we have presence of mostly of magmatic rocks, 10-12%, and it's about 15 so, but there are fragments of sedimentary rocks too, mostly sheets, shells, fragments of clays, etc. Quartz is 15%, and sometimes slightly more or less, but not quartz is not very frequent. Additionally, feldspars, potassium feldspars from time to time, not so frequent, are present mostly plagioclases, and biotite heavy minerals from time to time. Subgroup number 3C, its amount of clay mass, clay components 50 to 64%. Fragments of magmatic rocks relatively high, 34, and sometimes slightly less, 15. There are no sedimentary rocks, plagioclases, feldspars, biotite rare, heavy minerals rare too. Subgroup number 4, and clay minerals very high, it's 60 to 78%, so it's rich in thermally changed clay minerals. Fragments of sedimentary rocks are present. As you see, there are no magmatic rocks. It's typical for this group that there are sedimentary rocks, a mixture of fragments of sedimentary rocks. There is no magmatic rocks, and quartz relatively frequent, up to 32%, 34%, so quite high. Rare plagioclases and biotite rare, sometime present heavy minerals. And modern pottery, Shimu vessel, number of samples is 52, and what we have, clay minerals 55 to 67, and fragments of sedimentary rocks, magmatic rocks are absent, plagioclases, feldspars, so it's mostly in these ceramic masses are present clay minerals, of course thermally changed, and quartz. There are most important components, a few percent of plagioclases. Let's look under the microscope what we have. There is picture of clay mass around, fired at reducing atmosphere, and ceramic mass contain fragments of magmatic rocks belonging to the class of andesites. This is an example of clay mass, ceramic mass with parallel structure, confirmed by the orientation of grains as well as of small empty spaces. and composed mostly of quartz and fired at slightly oxidating atmosphere. All is brownish. This means iron is oxidated to iron oxides and it's brownish. Similar type, but composed of slightly other minerals. So we have a parallel structure confirmed by the orientation of empty spaces formed during preparation of vessel, pyroxenes, feldspars weathered, and heavy minerals. This pyroxene is zircon and other. And next similar type of pottery containing plagioclases. You see there are twinings, albitic twinings, fragments of andesites and trachites. This is trachite, pyroxenes, heavy minerals, and quartz. This scale. This is in section and photo of ceramic mass done near internal surface of the vessel. So first of all we have orientation of elongated grains, fragments of magmatic rocks type of trachite, admixture of heavy minerals, plagioclases, and internal surface of vessel is covered with black organic burned substance. This is what was boiled or prepared in the vessel is completely fired and is covering internal wall of vessel, is preserved as a small black layer. Next type of ceramic mass, composed mostly of clay minerals, thermally changed clay minerals. These photos are done at partially crossed Polaroids, so its picture is better for photography if it's done at these conditions. At cross Polaroids it's completely black. So clay mass, these surrounding grains, is slightly oxidated. This means that firing was done at presence of the air, presence of oxygen. There are grains of quartz, plagioclases, and small pieces of charcoal. We don't know if charcoal was added intentionally or by the way. Next picture of the pottery done at the area near internal wall of the pottery, and we have grains of plagioclases, quartz, etc., heavy minerals. We have thin layer of black substance. This is burnt substance which was cooked in the vessel, and it's especially interesting. There are especially interesting changes of the color, because as you see, this is light brown, dark brown, and near black. This means that oxygen during firing penetrated only a thin layer under the surface of vessel. Next parts, internal parts of pottery are not oxidated, are burnt, fired at conditions without oxygen. And this next example of the ceramic mass of ceramic from Peru, pottery from Peru, and fine-grained background, with presence of grains of plagioclases, fragments of rocks, amphiballs. It look like this, scale 100 micrometers, this means 0.1 millimeter. This is interesting because we have photo of external part of the vessel, cross-section, and this external wall of the vessel covered with black substance, and in ceramic mass we have small fragments of not mixed clay. This is clay fired but not mixed. This means that pottery was not well mixed, ceramic mass was not well mixed, and are preserved still all time, preserved fragments of primary clay. This means that this mass was made as a mixture of this type of clay with fine grains of quartz and other. This is interesting picture because it's done, this thin section is done near of external surface of the vessel, and we have this dark ceramic mass with fragments of trachytic rocks, this and this, slightly weathered, with fragment of quartz and other, and small layer of slime covering external wall of vessel. This is slime made using pure clay. And next, and it's example fragment of trachytic rocks with characteristic structure and composed of mostly of elongated crystals of plagioclases, and ceramic mass that dark, burned at reducing conditions without oxygen. And next photo, one can see there this change of the color of cross-section of the pottery, of the wall of the pottery, near external part of vessel, of cross-section of vessel. The color is brown, this part is oxidated, but internal part of wall of vessel is black. This means was burned, fired without oxygen. So oxygen penetrated only small part, less than 100 micrometers, near the surface of the vessel. This situation suggests the burning of the pottery, firing of the pottery at reducing atmosphere and cooling of pottery at the presence of at conditions where oxygen was present. So oxidation is not because of firing. Oxidation is the result of the cooling of pottery after firing. And next example of structure, parallel structure, one can see elongated crystals and empty spaces are orientated. Big fragments of plagioclases, type of andesine oligoclase. This means plagioclase is typical for magma, for rocks representing andesites, and again small thin layer covering internal wall of vessel. This is seen as thin layer, but this is cross section. This means this is again material cooked in the vessel and burnt it's possible to look more closer using scanning microscopy to see what is this, but it was not up to now done. And this typical example of pottery burnt at reducing conditions. Ceramic mass is black. There are present pyroxenes and various other heavy minerals and fragments of magmatic rocks representing andesites, but firing, of course, was done without presence of air, without presence of oxygen. Let's look for X-ray examination, X-ray diffractometry. For most of samples were done X-ray analysis for determination mostly of clay minerals, but as is seen on these X-ray patterns, because of heating, because of firing, clay minerals were completely changed, altered to the masses not crystalline, representing kinds of preliminary phase, preliminary stage of glass, let's say something similar to glass. So it's very difficult to say now what type of clay minerals, primary clay minerals, were used for preparation of the pottery. But my experience and investigation of other things at this area, other samples, not pottery but natural samples, documents that mostly clay minerals are represented by smectite and illite. Kaolinite is not very frequent. So after it's possible to say that after firing these minerals representing group of smectite, in part illite, are altered to type of not crystalline semi-glassy substance, building main background of the pottery. This is this small heel on the diffractograms on X-ray patterns. And of course all these peaks are typical for and easy for recognition, for determination. There is quartz, there are feldspars, various acidic plagioclases and potassium feldspars. Sometimes is present calcite or carbonates, but there are rare, etc. And more details one can find in this publication, in this paper. It's not new, but data are still representing relatively good level of examination, and is prepared new book now is printed concerning pottery of North Peru. So welcome to see details, especially this archaeological part, because now my lecture mostly was about mineralogy, petrography, technology of firing, but in this publication, in this paper, there is a lot of data concerning archaeological phenomena prepared by Professor Andrzej Chrzanowski. So thank you for listening. A specialistic lecture, so not everybody will be interested in this, but there is a few people in the world interested in mineralogy of Peruvian pottery, ceramics. So thank you very much, and see you again next time.